Already round 2 for testing. What we're going to do is I'm going to go ahead and turn the power on to the circuit breaker. And then what we're going to do is going to turn that knob on up there, which turns the board on. And we're going to leave that switch off. It's got his DMM. Everything's hooked back up original. And he's going to check across the 2 terminals there. He's got 4.5 volts AC coming in from this wire here, going back to the plug. Should be 2 120s, you get 240. He's just checking it there just to see the same thing, get the same results, 4.5 volts. And if he checks this one, which is a supposedly good outlet, he's going to, just got to move over here. Got the same thing, and probably until we turn these on. Check that one there. Same thing. Okay, same thing. But now we're going to turn ultrasonic cleaners on. And the one right to his right, this is a good one. So let's check this one. We should get the 200 and some volts. Just open the same 2 wires. And he's got 210 volts, which you'll have the same on those leads there, which is just feeding that bar. 210 volts, because that's the good one. Now this one, we're getting across both. We should get the same thing, but we're only getting 5 volts. And he checks across that bus bar, or no, whatever you want to call that there. He's only getting the 5 volts. So if you remember from the first video, on these legs here, if we took one leg to ground, we would get 120, one leg to ground, we get 120. On this one, same thing, one leg to ground, 120, and one leg to ground, 120. The good one, if you check across it, you get your 210 volts. On this one, we're not getting it, we're just getting 4 or 5 volts. So there's an issue with that. So now what we're going to do is we got both ultrasonic generators unplugged to the outlet back there. We're going to go ahead and turn the main power on, which powers up the board. We're going to leave the ultrasonic cleaners off. He's going to probe across both 120s. So you should get your 200 and some volts. You can see there, both across 120 on the front outlet. He's got 202. Well, if I push this button here, it goes to 208. Turn it off, 202. On, 208. That's the good outlet right now. Now he's going to go to the back one. Same thing, he's got 202. Should go to 208 when I turn it on. Turn it on, no change. Off, no change. On, no change. Off, no change. So what we're going to do now is we're going to swap the wires on the circuit board, and the outlets will switch. So we swapped the wires in there. We got this back on. So he's going to check the front outlet just like we did last time. Across both 120s. So we got 202. It should go to 208, right? When I turn it on. But it doesn't because we swapped them in the main board there. Off. On. No switch. Now he's going to go to the back outlet. And it should move to the back. 202, turn it on, goes to 208. Off, reconnect there, yep. 202, 208. 202, 208, and 202. So what does that tell us? That outlet's good. Both of those outlet receptors are good because you swapped them in the board. So this one of these ultrasonic cleaner, depends which one it's plugged into. Both of these ultrasonic cleaner unit generators are good, but there's an issue with we're not getting the 200 some volts across both 120 phases there, and yes, we're gonna have to troubleshoot and go more from there.
Okay, so what we had was we had a fault on Gen 1. So we assumed that was the circuit that we were troubleshooting this whole time. That was the generator that would not work. Whichever generator we had plugged into this circuit was not going to work because of the fault. Since then, we've shot actually continuity between these two wires on Gen 1 and Gen 2 to the actual generators, all the way through the outlet. So we now know that the one that doesn't work, whichever generator you have plugged into Gen 2 circuit, does not work. So then what we did was we measured across each two legs, which they all have 120 to ground on them, but if you shoot across them, you have about 5 volts on this one when you turn it on. This one on Gen 1, which we thought was the bad one, has 220, 210. It's good to go. So this circuit's good, this circuit's bad. So then I was like, well, let's make sure that everything else is good. So we unplugged. The heater circuit on this board is the exact same as Gen 1 and Gen 2. It's right over here. So I took Gen 1, Gen 2 wires from the generator and literally just put them into the heater circuit. So just to see if I could get both generators running at the same time. And we turned on.
Get the breaker here quick.
So if you turn on power, right now we have Gen 2 plugged into the heater circuit and Gen 1, which we already know is good. So you turn it on, and you turn on the generator button. It's only going to turn on one generator. You turn on the heater button, which is going to supply our other generator. They both work. So we know 100% everything is good, and now we're going to have to start troubleshooting Gen 2 output.
Alrighty, so now we got the oscilloscope hooked up. This is the one that's working right now. So we got channel A, channel B on the oscilloscope, channel A to ground, 120, channel B to ground, 120. And if you look, the phases, we got 60 hertz, 122 volts. If you did the math, you could figure out the 60 hertz or put it on the oscilloscope. But the phases are perfectly in line. Now what I'm going to do, if you can, I don't know if you can reach over with your other hand, he's going to turn it on. As soon as he turns it on, look, the phase shifts. So that's how it's working. The phase shifts over to get our 210 or 220 volts. Now if you go ahead and turns it off, the graph will line back up. Now I know this is a lot higher because of our auto scale on, but they're the same amplitude. But the phase lines up. If he turns it on again, this one's working, the phase will shift. Phase shifts, it turns on. Then he turns it off. They line back up. So now what we're going to do is we're going to go to the suspected bad one and do the same test. All right, so now we're on the bad circuit, Gen 2. Both of these phases are lined up. Again, one different amplitude. That's because of the scale, and I have set on the oscilloscope. But he's going to go ahead and turn it on, and they should shift, but watch, they won't shift. Go ahead. Nothing turns on. They don't shift. So that's why you're only getting 4 or 5 volts, or essentially 0. Turn it off. They stay the same. Turn it on, it should shift. No phase shift. Turn it off. We still get the 120 to ground, 120 to ground, but when you measure across, you don't get the 210 or 220 because this phase ain't shifting. And that's why this thing's not turning on. So now we're going to go back and troubleshoot down to the circuit boards.
So we didn't have the correct power issue or power output on Gen 1, right? I mean on Gen 2 right over here. So we're trying to figure out which one of these legs is not actually supplying its separated 120. So what I did is at first I took this wire and swapped it with the same wire on the heater, because we know that you can supply power from the heater to the generator and it will work. So we know this circuit is good. So I swapped these to see if I could use the heater, just the one leg of it, to get the generator to work. So then I would know that this one is missing. But when I swapped them, nothing happened. But then I did the same thing with this leg from the heater, and the generator kicked on. So that means that I can use this leg from the heater to power this generator. So that means that this leg is good to go. It works. That part of the circuit is fine. This leg right here is missing whatever we need.
Let me turn the circuit breaker on just to show that. Turn that on. That.
And we have to turn the heater on just to.
Both work. So now we just gotta troubleshoot it down to that one circuit, because like you said, you split the circuit in half, so we got to troubleshoot it from that circuit there. Well, we found the problem with the ultrasonic cleaner unit. One of the transistors was bad, so we cut it out, desoldered it, removed it, desoldered one back in. About when that transistor was bad, we believed it caused a fault in the main control unit. There was so after we R-squared, removed and replaced the transistor, we debugged the control unit, and now both ultrasonic units turn on and everything works as advertised. So I just want to do a little bit of follow-up that everything is good to go with this ultrasonic unit now because of a bad transistor. And we had to debug it by meaning basically reset the factory settings on the controller, which wasn't letting the voltage go through because of the bad transistor. But it is all good to go now.